Hi, I'm Cameron Chai from azocleantech, and today I'm speaking to Giles Bourne, who's the CEO of Bluglass. How are you doing today, Giles?
Good, Cameron.
Fantastic. So, you guys have developed some interesting deposition technology that's quite unique. Can you tell us a little bit about that?
Sure, yeah. So Bluglass came about from 15 years of research at Macquarie University, and there was a very interesting development which was on how to deposit gallium nitride through a new method, and gallium nitride is a key component of LEDs. And so this research led to a commercialisation of the technology, where the technology was brought out of the university. We listed in September 2006, and we built a plant in Silverwater in Western Sydney. Into that plant we brought the team from Macquarie University, we brought the deposition technology, and from there we've continued the research and development, and we're moving towards commercialisation. The principle about what we have is really a lower cost way of making an LED. An LED is a market that's growing very rapidly, something around 20% per year. The chip market is worth about $6 billion. But along the way of developing the LED, we also discovered a number of other advantages of our process. So the business as a whole really is there to build equipment, deposition equipment, reactors as we call them, and develop a process around growing gallium nitride crystals. And so LED has been our main business, but since then we've developed other businesses as well.
Okay, and the technology that you guys have, it's called RPCVD, which stands for?
It's a bit of a mouthful, but it's remote plasma chemical vapor deposition. The CVD system is quite common, but the technique of remote plasma, it's a way of getting the atomic species of nitrogen which you need in the growth, and so that's really where we've developed our expertise. And around that, we've ring-fenced it with a number of core patents, some to do with the apparatus and some to do with the actual product that comes out.
Okay, and obviously if anybody wants more information about that, they can go to your website. And they can obviously refer to the podcast interview that we did some time back.
Correct, yeah.
Right, but more recently, you guys have used this technology in the solar energy industry?
Correct. Well, this is a relatively new breakthrough for us. What we realised that nitrides, the area that we're in, is a relatively exciting area in the solar space, because nitrides, particularly indium gallium nitride, has the potential to have much greater efficiencies in conversion rates. And indium gallium nitride has been explored by a number of groups to date. But what we have is a low temperature process for deposition. And the lower the temperature, essentially, the greater the content of indium you can grow in the crystal, the higher the efficiency. And I won't go into the deep science, but the theoretical efficiencies for an indium gallium nitride solar cell can be greater than 50%, which is an order of magnitude greater than what's out there at the moment. So in the work we did on LEDs, we read a number of papers, understood the advantages of our process. So for the last 18 months, we've been focusing on how we could capitalise on our low temperature process for the solar space. And recently we made a series of announcements about setting up a solar-based business, which we are now calling Blue Solar. And along the way we applied for a fairly significant government grant, the Climate Ready grant, and we were awarded a 4.9 million grant from the Commonwealth Government about a month ago, which will help us get to that proof of principle into pilot manufacturing on our solar technology. Again, our business is all about manufacturing reactors, developing a process. What we'd like to do, and what we intend to do, is actually move further downstream and actually get into cell production itself. And the initial objective for our business would be to look at the concentrated photovoltaic market, where you concentrate the sun many times onto a high efficiency solar cell. But we wouldn't limit ourselves exclusively to that. There is the opportunity to go into the sort of flat panel market as well. That's the sort of phase 2 of our business.
Alright, so it sounds like exciting times for you guys at the moment.
Very exciting times, a lot of exciting times ahead. You know, not without its risk, of course. You know, it's early days and we've got to move rapidly from where we are today through to full proof of principle concept into pilot manufacturing. And one of the things that we'll be doing to get to that point will be looking for partners in this space who are down the value chain, who can come in, partner with us, and experts in perhaps cell conversion. And so we can use our expertise in deposition technology and utilise the expertise of companies out there who have already making solar cells and want to get more efficient solar cells. So that is the objective, and it's the program that we're working on with the Commonwealth Government is essentially a 3-year program to get to that, and of course we'd like to expedite that and move as quickly as possible.
Excellent. Alright then, well, it sounds like we should be keeping an eye on you guys and what's going on with you guys. And no doubt you'll have some announcements in the not too distant future with some of your developments and things like that.
Yeah, well, thank you, Cameron. I appreciate your time today.
No worries. If anyone wants any more information about your company, they can go to
www.bluglass.com.au.
Fantastic. Alright, Giles, thanks very much for your time.
Thank you, Cameron.